By the end of this, you'll drop a messy CSV into Contrive and walk away with a clean, standardized dataset. No formulas, no macros, no staring at duplicate rows for an afternoon. I'm talking about a raw file with date formats all over the place, names split or merged, and missing values that break your analysis. You'll have a normalized version ready to load into any tool. Contrive does the heavy lifting automatically. That's the promise. Let's see if it holds up. If you've ever cleaned data by hand, you know the pain. It's not the analysis that kills you. It's the hours before that. You're a data analyst pulling a sales report, and half the entries have January 5th, 2023, while the other half use January 5th, 2023. A marketer merging lead lists from 3 sources, and the same contact appears 3 different ways. A researcher gathering survey responses, and someone typed mail, while another wrote This feature is for anyone who touches raw data and wants to skip the grunt work. It removes the manual sorting, the conditional formatting, the pivot tables used just to spot duplicates. If you spend more than 30 minutes a week wrestling with spreadsheets, Contrive's automated normalization is built for you. It's not for people who like fine-grained control over every cell. It's for those who want a clean baseline fast. You still review the output, but you're not building it from scratch. That shift saves real hours. The tool handles the boring parts, so you focus on the questions that matter. Walk through time. First, upload your file. Contrive accepts standard CSV or Excel formats. Don't clean anything beforehand. The whole point is that it starts with the chaos. I upload a file with mixed date formats, trailing spaces, and inconsistent casing. The system scans the entire dataset and generates a profile. That step matters because it detects patterns across all columns. It flags how many unique values exist, where nulls appear, and which columns look similar to each other. You're not deciding what to fix. The tool tells you what needs attention. Next, look at the suggested transformations. Contrive lists each issue it spotted. Date columns get a standardized format. Text columns get trimmed and case normalized. Numeric columns get checked for outliers. You approve each suggestion individually. That's key. You're not handing over control blindly. You see the before and after preview for every transformation. If a column has not applicable and null mixed in, it unifies them into a single null marker. If a column has USD and dollar in the same amount field, it strips the currency symbols and forces a consistent number type. Each step has a reason. Approving one keeps the logic transparent. Skip what you don't need. Then, handle duplicates. Contrive groups rows that look similar. It uses fuzzy matching, not just exact equals. 2 rows with John Doe and John Doe get flagged as potential matches. You choose which one to keep or merge. The tool scores the confidence level on every match. A score of 98% means it's nearly certain. A score of 75% means you should check manually. You're making the final call. This step alone saves an hour. Most manual cleaning misses fuzzy duplicates because they're hard to spot. Contrive surfaces them all in one list. After that, define your schema. This is the normalization part. You tell the tool what each column should be. A column with male and M gets mapped to a controlled vocabulary. You create the mapping once, and it applies to the whole column. Same for country names, product categories, or any free text field. The tool remembers these rules. Run the same type of dataset again, and it applies the same mappings automatically. That's the real time saver for recurring work. You don't rebuild the rules every time. Finally, export. Choose CSV, Excel, or a database-ready format. The clean file downloads with a summary report. That report lists every change made, so you can audit it later. No black box here. You know exactly what happened to your data. Total time for this process on a 10,000-row file? Under 5 minutes. That includes upload, review, and export. Manual cleaning would take 2 hours minimum. The workflow forces you to approve each step, but that's a feature. It keeps you honest and keeps the output reliable. I tested Contrive on a real job. I took a customer database with 8,400 rows. The file had 3 date formats, phone numbers with and without country codes, email addresses with extra spaces, and 212 duplicated entries with slight name variations. I ran it through Contrive. Upload took 40 seconds. The scan profiled the data in under a minute. I approved 94 suggested transformations and dismissed 12 that didn't apply. Fuzzy matching found 187 potential duplicate pairs. I merged them into 154 unique customers. Total processing time was 4 minutes and 20 seconds. Export came out as a clean CSV, 6.8 megabytes. The original was 9.1 megabytes. Output quality was solid. Dates were standardized to ISO 8601. Phone numbers followed a single E.164 format. All nulls were consistent. I loaded the result into a database, and it accepted everything without errors. The summary report was clear, listing every transformation count. Cost was just the time spent, which totaled 5 minutes of active work. Compared to a manual cleanup that would take 2 to 3 hours, this paid for itself instantly. The numbers speak for themselves. That's a real test, not a demo. Now, the honest limits. First, Contrive struggles with ambiguous data. If a column has mixed types, like numbers and text in the same field, it can't guess intent. You get a recommendation to split the column, but it won't do it automatically. You're stuck making a judgment call. Second, the fuzzy matching isn't perfect. It flagged a pair of Robert Smith and Rob Smith as an 85% match. That's correct. But it also matched and Lee at 70%, which was a false positive. They were two different people. I caught it, but it required checking. If you push it on very large datasets, say 500,000 rows or more, the matching slows down. It'll process, but you're waiting longer and the confidence scores drop. The tool also doesn't handle geographic normalization well. Postal codes from different countries confuse it. It'll standardize the format, but not validate against official databases. You should not use this. If your data is deeply structured and your workflow is already automated with scripts, you don't need this. It adds a layer of manual approval that slows you down. If you must control every transformation with custom code, skip it. And if your data is so clean it doesn't need normalization, don't bother. The tool shines on messy, real-world data. It's not a replacement for careful domain knowledge. It's a starting point, not the final word. The obvious alternative is OpenRefine. It's free, open source, and has been around forever. It offers granular control with scripting support. You can write GRL expressions to handle edge cases that Confine wouldn't even attempt. It also runs locally, so you're never sending data to a cloud server. That wins if you handle sensitive information under strict privacy rules. OpenRefine excels when you need to build a complex transformation pipeline that runs repeatedly. Its clustering algorithm for duplicates is powerful. In one situation, it clearly beats Contrive. If your dataset is over 1 million rows, OpenRefine's performance. It's built for heavy lifting. Contrive's interface gets sluggish at scale. So, if you're a data engineer dealing with massive files weekly, OpenRefine is the smarter pick. It has a steeper learning curve, but the payoff is speed. For casual users, it's overkill. For professionals, it's a trusty weapon. That's the one place where the free tool beats the paid one. Your next step is simple. Take one dirty CSV you've been avoiding and upload it to Contrive. Don't clean anything first. Run the scan, approve the suggestions, export the result. Time yourself. See if you beat your usual cleanup time. That test tells you everything. If it saves you an hour, use it. If not, you've learned something. Then, build interactive dashboards with natural language queries.